Okay, so we're going to study infinite geometric sum series. I've given you a series. If you look at it, the R of this series is 3, correct? And the numbers keep getting larger and larger. And this is an example of where you cannot find the sum. It doesn't work. If I add these up, I'm just going to, the next number I would add would be 1, 3, 9, 27, 81, 243. The numbers just get bigger and bigger and bigger. So you can't find the sum, okay? But on the next one that I'm going to give you, okay, so on here, this has no sum. Which makes sense because the numbers get bigger, right? Okay, when you look at a problem like this, and I still think it's strange that if the series goes on and on and on, you wouldn't think that you would be able to find the sum, right? I mean, it's infinite. How could you find the sum of something that keeps going and going? But you actually can, okay? And let me show you this. Let's look at this one, and we'll do one drawn out long, and then you'll get the concept and it'll make sense, okay? So 81, 27, 9, 3, and 1. What is R, guys? Nope, 1/3, right? R is 1/3 because you're dividing or multiplying by 1/3 every time. So if I keep going with this series, 1 times 1/3, I would have 1/3, right? I would have 1/9, 1/27, 1 over 81, and so forth. 1 over 243, and 1 over 729. What's going on here with these numbers? They're getting bigger or smaller? Smaller. Which, though, even though the numbers are getting smaller, it wouldn't seem to me like you can find a sum. But this is what happens, and it's kind of interesting. Okay, first of all, I'm going to turn these into just estimations of decimals to kind of help us. It's 0.04, it's 0.01, 0.004, and 0.001. Right? So 1/9 is 0.1, 1/27 is 0.04, and so forth. Okay? Well, if I kept going, I mean, this 1 over 729 is 0.001, and we're only like 10 numbers down the series. It's hardly anything, right? This is 1/1000. Okay? So when you add these together, when you take 81, 27, 9, 3, and 1, you get 121. Let's see the calculator. There, is that better? Okay, so that's just the whole numbers, right? When I get ready to keep adding, and I'm just going to use the decimal forms just to estimate, I'm going to add 0.3, and I get 121.3. I'm going to add 0.1, okay, 121.4. I'm going to add 0.04, 121.44, right? And then I'm going to add 0.004. 121, and then add 0.001. Right? Is it changing? And I've added the biggest numbers so far, right? My next number is even smaller than 1/1000. And you know, it'd be like if you took a bucket of sand and you put it on the scale, okay? A whole bucket, right? And then you add a half a bucket, right? And then a fourth of a bucket, and a quarter of a bucket, and a 16th of a bucket. Eventually, when you keep going, you're down to adding a grain of sand, right? When you half it, when you keep halving it. So it's like adding, if you have a scale and you add a half a grain of sand, and then a quarter grain of sand, and then a 16th grain of sand, right? Is a 16th grain of sand going to add anything to your bucket of sand in weight? Right? None practically, right? So when they get smaller, they approach. So what number do you think we're going to say that the sum of this series is going to add up to? 122. 122. Let's apply the formula. Okay? Does that not make sense? Okay. So here's the formula. First of all, does it have a sum? Yes. And we've said the sum actually equals 122 is what we discovered. Okay? The formula is this. S equals the first term divided by 1 minus R. It's that simple. You can actually find the sum of a geometric, series by taking the first term and dividing by 1 minus r. Alright, go work. Let's do the problem we just found here. If I wanted to find the sum of number 2, I take the first term, which was what was our first term? 81, and divide by 1 minus 1/3. This is the formula. And if you put this in your calculator, what do you get? What? Right, when you type this in, you get 181 divided by 1 minus 1/3. Is that what was going on? Absolutely, wasn't it? Okay, so that's how you can find it. It's like adding such tiny amounts, it doesn't change much, right? But did it work for number 1? Did number 1 have a sum? So what's the key to this kind of problem? They have to get smaller, right? So r has to be between two numbers. It has to be between -1 and 1. Because if you multiply something by -1/2, it's still going to get smaller and smaller, isn't it? Okay? So here's the rule. Okay? The sum of an infinite series geometric series when the common ratio, or R we call it, right, is between -1 and 1. Okay, you can't always find the sum. In fact, that's a really nice key they'll give you. When they ask you to find the sum of something, they'll say, what is the sum of this infinite geometric series if it exists? Okay? And when you see the if it exists, it should raise like this little flag to say to yourself, oh, wait a minute. You might not be able to find it. Okay? And that should be your little clue to check and see what R is. And R has to be between -1 and 1. Okay? Alright, so let's do a couple of problems just like that. Okay, and it's find the sum. And like I said, they'll say if it exists. Okay, and obviously it'll say find the sum of the infinite geometric series or sequence, right? Because there's different kinds of sums, right? So you know which formula to use. This is the infinite formula. So if I tell you that a sub 1 is -7 and r is 5/8, would you be able to find the infinite geometric series sum if r is 5/8? Yeah, it's between -1 and 1. So yes, if you need a number line for yourself, draw one. Here's -1, here's 0, and here's 1. Both right here. I'm safe. Okay, apply the formula then. The sum equals the first term, -7, divided by 1 minus 5/8. So use a fraction form. The sum would be -56/3. Got it? It's easy. So number 2. The first term is 13 and r is 9/7. The directions remain the same. Find the sum if it exists. Does the sum exist? What do you think? And you know what will happen? Some of you guys will forget to check and you'll find the sum. It just is wrong. Okay? You can't find the sum because r is like 1.2 repeating. Right? 1 and 2 ninths. It's bigger than 1. So there is no sum. The series is getting bigger, bigger, and bigger. You only find the sum if it gets smaller and smaller. If you multiply everything by 1.2, that's like saying you're taking all of it plus 20% more, right? That's what that means. So they're going to get bigger and bigger. So therefore, you write no sum. Number 3. Oh, guys, that's the wrong number 3. No, it's right. It's right. It's right. This is in a different format. I apologize. First of all you have to just glance and find R. So what is R? What's R? 1/2. So can we find it? Are we allowed to find the sum? Absolutely. Yep. So R is 1/2. So let's find the sum by taking the first term and dividing by 1 minus 1/2. What's the sum then in this case? 2. Okay, number 4. Okay, these change signs, and that's the reason the rule is that R has to be between -1 and 1. So find R and see if it's between -1 and 1. What did you guys get for R? Okay, so am I allowed to find the sum? Absolutely. There's a number line if you're not sure. Here's 0, here's -1, and here's 1. Make 2/3 like right there. Good. So yes. So the sum equals the first term divided by 1 minus, be careful of your signs, 1 minus a -2/3. So the sum will be a fraction of 54/5. Okay, so we have one last problem like this, and then we're going to switch to one more topic. The directions are find the sum of the infinite geometric series. Okay, what do you think? What's R?
5.
Okay, R is 5, so can we stop? Right. Okay, so the answer then is no sum. Does that make sense? Okay. Alright, the last type. Okay, the directions are find the first 3 terms. Find the first 3 terms of the infinite geometric series. This is the directions. Find the first 3 terms of the infinite geometric series. So the sum is -16, and R is 1/4. Now guys, We have 3 different summation formulas now, right? So when they tell me to sum, you've got to pay closer attention to the directions. And it tells me that this is the infinite geometric formula. That tells you which summation formula to use. It's different, right, than the summation formula for a geometric. Now, the formula says the sum equals your first term divided by 1 minus r. So if I'm looking for the first 3 terms, all I have is the sum and r. Can I find the first term? Yeah, you look at the formula. I've got the sum and I've got r. So just use the formula to find it. So use the formula to find a1. Negative 16 equals a1 divided by 1 minus 1/4. So in your calculator, 1 minus 1/4 is 3/4, right? So to get a1 by itself, you're going to need to multiply negative 16 times 3/4. So what does a1 end up equaling? What's the first term? Negative 12. Good. So the directions were to find the first 3 terms. So negative 12. Then we're going to multiply times r, which would be what? No, negative 3. And then the next one would be negative 3/4. Okay, last problem. The directions are the same. Find the first 3 terms of the infinite geometric series. So I'm going to tell you the sum of the series is 48, and that r is negative 2/3. Looking for the first 3 terms. Careful of your math in the denominator of the double negatives. So you should really take 48 and multiply it by 1 2/3. So your first term is 80. Does that make sense?